we're asked to solve these absolute value problems. So the key for doing an absolute value problem is when you approach it, you need to make sure the absolute value is by itself. There's extra steps here, so if you recognize we have inequalities that are going on here. So not only do we have to approach it with the absolute value strategies, but we also have this extra work to do about finding out which regions the answer is. Remember, an inequality with an x means there's a whole slew of possible answers that could possibly satisfy the inequality. So let's go ahead and see how we approach these. All right, so when we do the absolute value or an inequality, it's really important that we look at the absolute value as an equal sign first, so we can find the critical values or endpoints. Once we know the critical values, then we can find out what those regions are. So the first thing we do is we make it into an equal problem. All right? Then when we have the equal problem from absolute values, it breaks up into two separate parts. The first part should be the easiest one. That's the one where you just drop the absolute value signs, nothing changes. And the other one is where you negate one of the sides. So I can either negate the right side or the left side. So if I negate the left side, I'd have to negative sign and distribute it. If I negate the right side, it's only that one number. That's a lot easier, so I'll choose the right side for this problem. Now, I'll go ahead and just solve for x. Minus 9, minus 9. I got x equals negative 4 for this one. Minus 9, minus 9. I got x equals negative 14. These are critical values. You have to use a graph to see the regions that are the possible solutions. So I like having 0 as a placeholder, and the first one that I see is a negative 4, and then I have a negative 14 over here. All right, now we go back to the original problem to see how we mark this. The original problem has an equal sign. So that equal sign right there means closed circle. Closed circles. So wherever I have the critical value, those are also solutions. So I close the circle in on negative 4, that's a critical value, and I close the circle in at negative 14, that is also a critical value. So now I need to do test regions. I need to see where are the possible solutions. So I don't know if you can tell, but there are 3 fields here that I need to deal with. So the fields are this last one, this middle one, and this first one here. All right, so we have to pick a test value in each one. Don't pick one of the critical values. That doesn't help us. We need to pick a number in the test region. So I like picking nice numbers with 0s or 5s in them. So I'll go ahead and pick negative 20 right here. Negative 20 is on this side. In here, I'll pick negative 10. Negative 10's in there. And I like 0 wherever it lands. Okay, so I need to test those to see if it's true or false in the original problem. So I'll go ahead and I'm testing now. And I'm testing on x plus 9 greater than or equal to 5. And my first test point is going to be negative 20. So when x equals negative 20, what happens to the inequality? So I plug it in. Negative 20 plus 9 into absolute value greater than or equal to 5. And this is a question that I'm asking. I like having that question mark because I want to know, is this true or false? So when I calculate this, that's negative 11. Is that greater than or equal to 5? Well, the absolute value of negative 11 is 11. Is that greater than or equal to 5? And yes, it is. That is true. Yes, it is true. So on your graph here that we made, I like putting a big T. But for now, I'll go ahead and put true. Okay? So we need to keep testing points. Looks like I'm going to run into my problem here. That's fine. Next point I'm going to test for x plus 9 absolute value greater than or equal to 5 is negative 10. Plug that value in to the function. Negative 10 plus 9 into absolute value. Is that greater than or equal to 5? Sometimes you can do these in your head, just be careful if you do. This is negative 1 when I simplify inside the grouping symbol. Negative 1 greater than or equal to 5. Is that true or false? Is negative 1 greater than or equal to 5? No, it is not. It is false. Okay? So this is a false. And the last one, I am testing on my x plus 9 greater than or equal to 5. So make sure we're not messing with that problem. And I'm testing x equals, what's the favorite number to test? 0. Plug that in. 0 plus 9 into absolute value, is that greater than or equal to 5? Absolute value of 9 greater than or equal to 5. Is 9 greater than or equal to 5? 9, is that greater than 5? Yes, it is. This is true. So now I have a true here. All right, we're almost done. So now in our solution on the program, they like it in set notation, so let's write it in set notation. All right. We always start from left to right, moving this way. That's how we read a number line, a graph, English. We move it from left to right. So this arrow right here is going to negative infinity. This arrow here is going to positive infinity. So I go from negative infinity, so here's my final solution, negative infinity in set notation, and I go to negative 14. Negative 14. It's a closed circle. It's an equal sign. In set notation, a closed circle means a bracket. And then we have a skipped space, false. That means there's no solutions here. And then now we have more solutions on this outer end. So in set notation, this is the union sign. It's just a big U. It means together with. These are our two answers together. And we start at negative 4. We start at negative 4. Notice we have the closed circle. It's our critical value with an equal sign. That means it's a bracket. We include the negative 4. And then we go to where? We go to positive infinity. Can you ever touch the end of infinity? No, it never touches, so it's a parenthesis. We never get there. And there is our solution. Everything looks good. I'm going to go ahead and break up the videos here. One other thing before I start on the next video is that just as a note, so don't jump to this, don't assume it all the way, always, but x is on a greater side of this for the absolute value. X is on a greater than side. So usually on the greater than side, your solutions are going to run out into the infinities. So just kind of be careful with that, but it's just sort of a mental check. Greater than, are we on the outer ends of this? And yes, we are.